Hi everyone. For this video, we're going to discuss how do we add vectors and how do we graph them. Okay, so let's have an example here, vector A and vector B with their components, with their x and y components. So we know that's x and y. Okay, so what we do is, so let's put the notation. So vector A plus vector B is just equal to your x and y components So what we do here is we just add the components. So for x, that would be 3 and 1. And for y, that's 4 and 2. So that's 4, 6. Okay, how do we put this in a graph? So let's denote vector A as yellow and vector B as the blue one. Okay, so this is B. So let's graph first vector A. So it's a 3, 4. Okay, so let's connect that. We can call the two parts of the vector like the initial point and the end point. Okay, or in other books they call that the tail, which is the initial, and the head, this one is the end point. Okay, but for this video, let's just call them initial and end. All right, for vector B, it's at 1, 2. So here, okay, oops, let's connect. So from initial, there you go. All right, so how do we do this? So let's start with vector A, the yellow one, and then we connect vector B at the endpoint of vector A. So let's transfer that over here. It's going to look something like that. Okay, so therefore, so from the starting point of vector A, let's connect to the endpoint of vector B. So this is our vector A plus vector B. Now, if we want to start with vector B, so it's like vector B plus vector A. So from the endpoint of vector B, we will draw vector A. Okay, it's not straight. Okay, something like that. So we'll still end up with the same point, the black line. So from vector B initial to the endpoint, of vector A. So it's the same. So therefore, we can say that vector addition is commutative. So vector A plus vector B is equal to vector B plus vector A. And the sum of the two vectors is what we call the resultant. Okay? So that black line that we just drew to connect the initial point to the endpoint of the other vector is what we call the resultant. Let's have another example with vector u with components 3, 4, and vector v with components 5, negative 1. So to add these two vectors, so look the same. Okay, so vector u plus vector v. So we just add the x component, so 3 plus 5, and the y component, so 4 plus negative 1. So the sum, the answer is 8, and 4 plus negative 1 is 3. Okay, let's graph this. So let's graph first vector u with 3 and 4 component. So the initial point to the endpoint. So this is vector u. And then we have vector v at 5, negative 1. So 5, negative 1. So that's that. Alright, so now let's connect the endpoint, initial to endpoint, and endpoint initial of the two vectors. So let's do vector u and then vector v. So vector u is the yellow one. So let's transfer this vector v at the endpoint of vector u. Alright, and then let's draw the resultant. So this is the resultant. So this is our vector u plus vector v. Next example is we have three components of our vectors. So we have x, y, and z or z component. So what we will do is just add the components. So for x, we have 2 plus 4, y, we have 1 plus negative 3, and then for z, we have 3 plus 1. Okay, let's add that. So we have vector c plus vector d will be 2 plus 4 is 6, 1 plus negative 3 is negative 2, 3 plus 1 is 4. So this is our answer of vector c plus vector d.